All right. I think we're starting. Thank you for joining us at IMX Virtual 2020. My name is Alden Satoon. We are presenting on Tier 3 propulsion solutions. I'm here with Chris Senner, our Vice President of Sales and Marketing. For those of you who aren't familiar with us, Karl Senner is the exclusive sales and service representative for Reinches Marine Transmissions and steel prop azimuth thrusters throughout North America. Karl Senner provides the maritime community with the highest quality marine propulsion equipment. These products are backed by superior service and allow Karl Senner's customers to optimize vessel performance, safety, and operating hours. We are headquartered in Kenner, Louisiana, and have 3 satellite offices in Houston, Texas, Paducah, Kentucky, and Seattle, Washington. So here are some major milestones throughout our history. I'd like to highlight that we've been in the inland market since 1967, when we sold the first Reinches gearbox in the U.S. to LaBeouf Towing. The inland market has been the backbone of our success for over 50 years since the company's founding in 1972, or almost 50 years. Also, we participated in our first diesel-electric project in 1998 with Secor. We've supplied Reinches gearboxes between an electric motor and fixed-pitch propeller shafts in an anchor handling tug. Also, we introduced sea drives to the line haul industry in 2016. So why did we decide to choose on Tier 3 creative propulsion solutions? The changing regulatory environment, we've seen common interest among owners to remain Tier 3. For certain power ranges and vessel types, this is achievable and beneficial through creative solutions, including diesel mechanical, electromechanical hybrid, and diesel electric arrangements that are all Tier 3 EPA compliant. Each solution has its own benefits to the inland market, and we're excited to explore those benefits with you. Some of these solutions are new to the inland market, but all of them are proven technologies in other maritime sectors that Karl Senner LLC has direct experience with. Before diving into these arrangements, I'd like to thank ABB, BAE, and the Shear Group for laying the foundation for diesel, electric, and hybrid. On the virtual IMX platform, we are going to focus on the propulsion aspects of the arrangements. So for the operators in the audience, there are particular arrangements and power ranges that we are targeting. Please be aware that these power ranges are flexible, especially hybrid and diesel electric. So we'll review twin screw, 1600 horsepower diesel mechanical, as well as 2400 and 3200 diesel mechanical. The 3200 is a twin input gearbox that can utilize 4 engines in a twin screw application. We'll look at 2150 hybrid twin screw and 3200 horsepower hybrid triple screw, as well as 2150 diesel electric twin screw and 2900 diesel electric twin screw. And please be aware that every arrangement and power range is available in fixed pitch propeller as well as azimuth thruster. So we're all very familiar with fixed pitch propeller diesel mechanical arrangements. Today we'll look at multiple diesel mechanical propulsion arrangements that all utilize Tier 3 800 horsepower engines for building blocks for each design, including the 1600 twin screw, obviously the most simple solution, 2400 triple screw, and 3200 twin screw with quad engines possible through twin input, single output gearboxes. And again, all available in fixed pitch propeller, shafted propellers, or Z drives. So we're seeing some operators do twin and triple screw with 800 horsepower as building blocks, and some are choosing to use deeper ratios and bigger wheels in hopes that they'll push harder and push closer to 1,000 horsepower per shaft line. So one of the more interesting arrangements and solutions that hasn't gotten much buzz yet is the twin input diesel mechanical twin screw arrangement. You can see here in this general arrangement from a different application, not for the inland market, that there is two engines going into a single gearbox with a single output shaft into a propeller. This arrangement offers the highest total horsepower for the Tier 3 arrangement in a diesel mechanical solution. Again, this can get you up to 3,200 in Tier 3. We've been providing dual input, single output gearboxes for over 40 years. However, they're most commonly found connected to CPPs because they're non-reversing. However, the same gearbox can be applied in front of a Z drive, which can provide reversing by rotating the unit. For a fixed pitch propeller, a reversing gearbox is required, and it's currently in the design phase at Reinches and should be available in mid-2021. If you're interested, please contact us. Utilizing 4 engines obviously has the benefit of redundancy. However, it's always important to compare the engine curve to the propeller curve to make sure a single engine can absorb the load of the propeller rated for twice the amount of power. So here are some pictures of the gearbox. It's called the DLG. It is twin input, single output with horizontally offset input shafts. And it is available in multiple offsets with diagonal and vertical as other choices as well. Horizontal is the most popular choice, but there is flexibility in offsets for engine room design. So here is a diesel mechanical Z-drive application. There are now many Z-drives in the inland waterways. We've come a long way. Steerprop and Karl Senner can offer units starting at 800 horsepower for the inland waterways applications, and we go up significantly higher than that to 30,000 kilowatt. But for the inland market, we can support you from 800 horsepower as high as you'd like to go. So now we're moving on to electromechanical hybrid. We're focusing on 2 power ranges, specifically 1,600 kilowatt or close to 2,150 horsepower in propulsion power, and 2,400 kilowatt, close to 3,200 horsepower in propulsion power. Whenever you're looking at converting electrical power into propulsion power, it's very important to note that there are losses. It's around 10%. This arrangement offers full power upriver if elected, and 3/4 power and diesel mechanical only going downriver if elected. The main engines and generators always remain at optimal loads regardless of operating mode. And again, these solutions are available in fixed pitch propeller or azimuth thrusters. So focusing on the Reinches hybrid system with shafted fixed pitch propellers, very similar to the conventional setup. We place a motor after the gearbox for additional operating modes, diesel only. Again, that would be a downriver application, PTI only for slow speed maneuvering, and boost for combination diesel and electric motor for going upriver for max power. When in PTI mode only, the electric motor has no slow speed RPM limitations, allowing the propeller to reduce to 1 RPM if needed without slipping a clutch. This gives the operator max control of the propeller RPM. When operating diesel only mode or selecting a hybrid system, it's important to compare the engine curve to the propeller curve to ensure the engine can absorb the load of the propeller rated for 20% higher than the engine. And the motor power can come from gensets or batteries. So moving on to steer prop hybrid arrangements. Pretty similar concepts to the Righteous setups. In the first arrangement on the left, we've got a motor aft of the unit. Steer prop can actually mount this motor directly onto the unit without a separate foundation. And you can control the inputs, the diesel input and the motor input independently by use of a clutch between the engine and unit and controls through the motor. The second arrangement has an external clutch and motor in the shaft line. Again, this does allow for independent use of the inputs through the clutch. And the third arrangement has the most maximum control of the inputs through an external clutch and gearbox. However, we could incorporate the clutch and gearbox into a Righteous gearbox in one unit, so that wouldn't be separate units. So we are moving on to diesel electric. This is a twin screw arrangement with 3 generators. This can get you to over 2,100 horsepower in the figure shown below. And I meant for this to be a twin screw arrangement, but it's triple. We can also look at 4 gensets for twin screw. That'll get you up to about 2,900 horsepower. Again, with converting any electrical power to propulsion power, it's important to note that there's about a 10% loss in the conversion, which is accounted for here. This arrangement allows for fleet building blocks and commonality. Again, it's available in fixed pitch propeller and azimuth arrangements. And an operator could use the same gensets in the 2,100 horsepower and the 2,900 horsepower units. So we can offer steer prop LM units. It's an L drive as opposed to a Z drive with a permanent magnet motor mounted on top of the unit. So that is shown in the second figure. The first figure is an actual Z drive driven by an electric motor. The L drive saves quite a bit of engine room space. And the L drive eliminates the need for intermediate shafts. And the vertically mounted PM motor eliminates the upper gear set and clutch. There's no alignment work necessary. There's increased low speed maneuvering and RPM control through the immediate torque of the permanent magnet motor. Increased acceleration, again, through the permanent magnet motor. And there's design flexibility because you can place the gensets and electrical equipment throughout the engine room. They're not incorporated to a shaft line. So there's quite a bit of flexibility there. So diving into this a little bit more, there are there's CapEx savings due to no clutch, upper gear set, or intermediate shaft line to purchase, install, align, or maintain. The savings on the reduced mechanical equipment and the ability to install Tier 3 gensets as opposed to Tier 4 engines should offset the additional price of the electrical equipment, making the CapEx on the comparison nearly equal. Substantial OpEx savings can be found in reduced maintenance by spreading the total operating hours between gensets, which can be shut off when the load is not needed, an example, downriver. By alternating time between gensets, overhaul intervals are increased, and additionally, overhauls are not performed in the engine room, since the gensets can be swung out easily from the soft patch. Gensets do not require alignment, but only need foundation, mounting, fuel, exhaust, cooling, and electrical cable. There could even be a swing genset in an engine room or on the deck. The crew could swing. There are redundancy benefits depending on the number of gensets. For example, if you had 4 gensets on board and lose a generator, you're only down 25% of your propulsion power, as opposed to a traditional twin screw application, twin screw diesel mechanical application, where you'd be down 50% if you lost an engine. And there's commonality benefits. Diesel electric arrangements allow for a common generator to be used as a building block across an operator's fleets. As I showed you, between the 2100 horsepower and the 2900 horsepower units, you can use the same gensets as building blocks. One spare unit could be allocated across multiple vessels in the fleet. So, as I've mentioned a number of times, we can also offer diesel electric with shafted fixed pitch propellers and a Reinches gearbox. There have been some projects that have gone with shaft speed motors. We've done studies and found that the use of a gearbox with a high-speed motor is significantly less expensive with the gearbox and the motor combined versus a shaft speed motor, and it eliminates the need for an external thrust bearing. In addition to that, a high-speed motor is significantly smaller, weighs less, and it can be serviced quite a bit easier. And then you have the same benefits of serviceability, commonality, redundancy, and similar CapEx. However, CapEx and OpEx with shafted fixed pitch, you would have alignment during the installation and throughout the life of the vessel. So that went pretty quick, but I'd like to say thank you to the Shear Group for the vessel propulsion images. And if anyone has any questions, we are more than happy to dive into those. So Spence asked, what trends are you seeing in the purchase of propulsion equipment? So quite recently, we've seen a number of twin screw Tier 3 1600 horsepower towboats. I expect that we'll see more of that. And one thing we have seen is the deeper ratios with bigger wheels. So I think we're going to see more of that, especially if the 1600 horsepower with the deeper ratio, bigger wheels are going to run the dish, and operators are happy with how those 1600s push if they push like a 2000. So I think we'll see a lot more of that if that works out well for operators. We've gone through quite a bit of quoting exercises on diesel electric projects. I think everybody knows that hasn't come to fruition yet in the industry, but we are posed, and we are more than ready and eager to jump at any opportunities. That was a good question, Spence. And then again, we're continuing with Z drives in the inland waterways. Hey, Dave Lee. Yes, we have seen some triple screws. We participated in 2 triple screws with Golding recently, and those were Tier 3. Those were diesel mechanical, built at a master boat builder in Bayou Battery. One is commissioned and one is being commissioned. I think we'll continue to see that as well. Good questions. Thank you. Anything to add, Chris?
Yeah, Olin, this is Spence. I wanted to pop in here and say thank you for presenting. As all of you know,
absolutely. Thanks for having us, guys.
Oh, you bet. As all of you know, Karl Senner has a good, solid name in the industry, solid reputation, and we're happy you were able and willing to present today.
Absolutely,
it's great. And of course, they're on the exhibit floor. So anyone on this call, please visit them there. And we have all the contact information in front of you.
We've got another question.
Yeah, Spencer, I got another question here from Ingo Steller. He asked, is a fixed pitch drive with the bow thruster regarded as alternative for Z drives? I know that we've seen, I think, some bow thrusters have been installed on some barges, I think, before in the past to try and accomplish a similar effect. But I think the challenge you run into with the bow thruster being installed on the bow of a barge is the moving water past the tunnel over a certain speed, which is not very high. The bow thruster loses a lot of its effectiveness and makes it very difficult to try and control the vessel at speed, especially in currents and whatnot.
Why it's not popping.
Yeah, I see that in the chat box there. For any questions, go to the right, the Q&A. It'll be more readily available to the speakers.
Okay, well, if there's not any other questions, that'll be it. I thank everybody for coming. My contact's up on the screen. Please drop an email if you have any other questions. We're eager to help.
That was great. Thank you very much.
Thank you.